So for this lesson, we're going to talk about rotations, and we're going to talk specifically about rotations on a coordinate axis. The first thing I want to get down is the notation down here. This is the notation we're going to use for rotation or rotating an object. First, we have the uppercase R, which stands for rotation. This right here is going to be the point of rotation. What will be nice is on a coordinate plane, it will always be the same point. This number right here is going to represent the degree of rotation. We are only going to deal with 3 degrees of rotation: 90, 180, and 270. Those degrees should be familiar to you. And then inside the parentheses right here will be the object we are rotating. In most cases, there we go. In most cases, it will be a triangle. Some cases, it will be a point. In this case, it's point P. So 2 quick things on this slide here that I want to just show you is the point of rotation. So the point of rotation when on a coordinate axis will always be the same point, and it's always 0, 0. So we will always be rotating around 0, 0. The second point I want to make is the direction of rotation. And this is a little bit weird, but we will always be rotating in a counterclockwise direction. I want to show you what that means. Okay, if I have an object here, let's call it a triangle ABC, and I want to rotate it 90, 180, 270, whatever amount of degrees, I'm going to be rotating it around the origin in that direction. That's a counterclockwise direction. If you might remember how there's 4 quadrants of a coordinate axis. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you can see them moving in the direction of the quadrants. So 2 big points there. Point of rotation, always 0, 0. Direction of rotation, always counterclockwise. Okay, we're going to start with a 90-degree rotation. You can see that by the notation that we have here. We're going to take triangle ABC. We're going to rotate it 90 degrees, and we're going to rotate it around point 0, 0. If you remember that we're going to rotate 90 degrees in a counterclockwise direction, so that means we are going to move in that direction. You can see I've already graphed the original coordinate points in the first quadrant, and we're going to take a look at what happens to these points after a rotation of 90 degrees around the origin. So what we're going to do first is we are going to take a look manually. Okay, so if you can see, this is your paper right here. What we're really going to do, what we're going to do is actually just rotate this paper 90 degrees and see what happens to this triangle. So if you can take your paper and literally turn it 90 degrees so that it looks this way. Now you're looking at this graph right here, okay? And I want you to read the coordinate points off the graph as if you were looking at this graph with proper orientation. So if I'm looking at this new triangle ABC, I'm going to record the coordinates over here. So I'm going to call this A prime. Now A prime looks like, if I count off, it looks like a -3 and a 1. If I look at B, a new B prime here looks like a -1, 5, and the new C prime looks like a -1, 1. So now that I've recorded those, get this out of here. Now that I've recorded those new points, I'm going to take my paper, rotate it back to normal, and now what I can do is plot those points, and I'm going to rewrite them over here. Alright, so this A prime became was -3, 1. The B prime was -1, 5. The C prime was -1, 1. Those were the points we recorded. So now I'm just going to plot those points. -3, 1 is here. That was A prime. -1, 5 is about here. That was my B prime. And C prime was -1, 1, which is right here. If I draw that triangle, there is my rotated triangle 90 degrees. A couple of things to take note. First, note what quadrant it's in. Okay, it started in the first quadrant, the original triangle, ended in the second quadrant, rotation of 90 degrees. The next thing we want to take note is what happened to the points. This is going to be a general rule. You don't have to be rotating your paper every time. So just take a look at A and A prime. Notice how the coordinates switched. The x and y coordinates switched. The 3 moved to the front, the 1 moved to the back, and the 3, which was the y coordinate, became -3. So we're going to make a general rule here and say that if you take any point, x, y, and you rotate it 90 degrees about the origin, that point is going to switch spots here. The y comes in the front, the x goes to the back, and the y is negative. So this is a very important generalization of what just happened when we rotated triangle ABC 90 degrees around the origin on this coordinate axis. In this slide, we're going to do a 180 degree rotation. You can see we have the same triangles, same coordinate points. Okay, and what we're going to do here is, you see I already graphed the triangle. We're going to take our paper, which you can see right here, right? You have your paper, and we're going to rotate it just to see what happens to the points now. So here we have our 90 degree counterclockwise rotation. Here we have our 180 degree counterclockwise rotation, basically turning it upside down. Now we can re-record or record the new coordinate points, A prime, B prime, and C prime. So let's do that. So we're going to have A prime now looking like -1, -3. We've got B prime looking like -5, -1. And we've got C prime looking like -1, -1. Now that's going to allow me to turn my paper back to normal. Okay, and I have my new coordinate points which I can plot. Alright, I'm going to rewrite them here just for my purposes, but you don't need to. So A prime became -1, -3. B prime became -5, -1. And C prime, -1, -1. So the first thing I'll do is plot those. -1, -3 for A. -5, -1 for B. B prime, that's A prime. C prime was -1, -1. And I could draw my triangle. And there you see a rotation of 180 degrees, again, counterclockwise. Now, again, two things to point out. The coordinates. The coordinates went from coordinate 1 and it rotated all the way through to coordinate 3. The second thing is what happened to the points. What's the general rule? So that's a very, very important thing to take away from this. If I had a point x, y, take a look at A, B, and C, or take a look at just A to A prime. What happened to the points? They both became negated. So what we're going to do is we rotate 180 degrees for any point x, y. The new point is going to be -x, -y. One important thing that I just want to note here is that if you have an original coordinate point that is already negative here, you still have to negate it. It actually would become positive here. So negating a negative would give you a positive number. All right. All right, the last one we're going to do is a rotation of 270 degrees. We have the same triangle. You can see here that I've actually already got the triangle graphed. And just to show you one more time, we want to do 270. We're going to take our paper with our original triangle. We'll rotate 90 clockwise, 180 clockwise, 270 clockwise. So it's like a 3/4 turn. So these are the new coordinates I'm looking at right now. I actually already recorded them. If you can see here, on the left side here, I recorded those points. A prime ended up being 3, -1. B prime ended up being 1, -5. C prime was 1, -1. So these are my new points that I got from my manual rotation. I'm going to plot those, check out what it looks like. So we have a 3, -1 here for A prime. We have C prime here at 1, -1. And B prime was 1, -5. And there is my 270 degree rotated triangle, again rotating counterclockwise 270 degrees. We went all the way from quadrant 1 all the way to quadrant 4. If you can pick up a general rule again that we're going to jot down here, if we take a look at what happened to the coordinate point after a rotation to 270, we're looking at a point that definitely the x and y switched places, but instead of the y becoming negative, this original x became negative. So we'll call that a y, negative x rule. Okay? So this last slide, I just want to wrap those 3 rotations up to the most important thing, the generalized rule that we came up with for each rotation. You can see here that what we're going to do is take any point x, y, and we're going to rotate it 90, 180, 270. So these are really what you need to take away from this slideshow. If I take a point and rotate it 90 degrees, we saw that the rule, or what happened to the point, was negative yx. Rotating it 180 degrees, we saw that both the x and y coordinates were negated, and for 270, we saw that it became y negative x. These are the most important things to remember. These will allow you to take any point on a coordinate axis and rotate it 90, 180, or 270 by applying this rule. And that brings our rotations lesson to an end. Thank you very much.